Hello everyone, welcome to my YouTube channel MK Maths. I am Karthik Mansali. In last video we have started the 3 marks question solving problems. So I have solved 2-3 questions in last video which may appear in exams based on the topic relation. And today we are also going to solve some problems 3 marks questions which is also very important. If you not watched that previous video, please do watch that previous video so that you will overall understand how to write a 3 marks question from the concept relation. So if you understand that problem, definitely next these problems will be very easy to write. First you have to understand the concept, and second thing you have to understand how we write here. So if you understand both concept and how to solve a problem, then definitely in that video definitely in this video you are going to learn some more problems, that too very easily. In same way what we have learned in previous video, in same way we are going to write same pattern for these problems also. I hope you understood the last video. If you not understood last video, please do comment in that video so that I can reply your comments, or I can clarify your doubts. So without wasting any time, let's move to our second question now. So let's start with the question. So here question itself says show that. So here question again they have given show that relation R. We have to show the some relation R in the set Z. Here Z is nothing but this Z indicates the integers. So Z is a symbol of Z is a symbol to denote a integers. I hope you all know about integers. Integers contain 1 2 3 4 5 6 and 0 -1 -2 -3. So positive numbers, negative numbers, and 0 it in 0 it contains. So okay, set Z of integers given by the R they have defined here. R, set R has ordered pair A comma B. Here they have mentioned ordered pair A comma B. In previous question they have mentioned ordered pair T1 comma T2 because they have defined the set T. Set T contains set of all triangles. But in this set, in this particular set, they have mentioning a ordered pair. In this particular set R, they have mentioning a ordered pair A comma B. Here A comma B means A is related to B. Okay, some element A which is related to B. So next this symbol is nothing but such that next here they are defining how A and B are related. Okay, now they are defining the relationship between A and B. So the relationship here is 2 divides A minus B. So 2 divides A minus B. This 2 divides A minus B means we have to consider two elements A and B from this integer set Z. We have to consider any integers. Consider any two integers A and B, and we have to subtract those two integers. After subtracting those two integers, we will get again an integer because A is an integer and B is an integer. So A minus B is also integer. So after getting a value from A minus B, we have to divide by 2. That number should be divided by 2. The 2 divides A minus B means this is the meaning. We have to consider two elements A and B. We have to subtract those two elements. After subtracting two elements, if we divide by 2, if it is divisible by 2, then we can say A is related to B. We can say A is related to B. If after subtracting A minus B, that number what we got answer from A minus B, that number is not divisible by 2, then A is not related to B. So like this they have defined a relationship between A and B. So to find a relationship between A and B, we have to subtract those two numbers A and B, and we have to divide by 2. If it is divided by 2, then it is a related, A is related to B. If it is not divided by 2, then it is not related to B. So this is the overall question. So we have to show R is a equivalence relation. This is our main target. We have to show R is a equivalence relation. To show R is a equivalence relation, we have to show reflexive relation, symmetric relation, transitive relation. So let's start with the one by one. So solution, first I start with reflexive relation. Reflexive. Okay. So reflexive relation. In reflexive relation, so our target I have already discussed in last video. What is our main target to show this reflexive relation? So here they have given an ordered pair a comma b. So reflexive relation means by definition itself says order pair a comma a belongs to R, means a element should be related to itself, then only if that relation exists in R, then that R we can call it as a reflexive relation. So here I am changing B. In the place of B I am changing as A, because I have to check the given relation which is related to itself. So B equals to A. So I am changing B as A. After changing B as A, if the relation has nothing changed, the relation is satisfied, then the definitely R is a reflexive relation. So here reflexive, our target is B. We have to change B as to A. Okay. So given, first let us write given. So what is given relation here? The given is 2 divides A minus B. This is the relation which has given in question. Okay, now our target is to show this relation is reflexive. This relation satisfies the reflexive relation. Okay, so next I am going to change 2 divides a minus B. A minus B is there. So now I am changing, in the place of B I am writing it as A now. So because to show reflexive relation, we have to show a element is related to itself. A element is related to itself. To show element is related to itself, here we have to change in the place of B as A. Now 2 divides A minus A. A minus A is nothing but we already know it is a 0. So 2 divides 0 as 2 is divisible by 0, because we can write 0 which is divisible by 2. So 0 is divisible by 2 is nothing but 0. We get an answer here. It means 2 divides A minus A. A minus A is nothing but 0. Here the relation is working for this A minus A. So here we can write which is true. Which is true. So what I have written, the relation 2 divides A minus A, which is true. If it is true, then easily we can write A comma A belongs to R. A comma A belongs to R for all A belongs to Z. For all A belongs to Z. For all A belongs to Z, it satisfies. So therefore R is reflexive. Therefore R is reflexive relation. Therefore R is reflexive relation. I hope you understood this problem. So next let's move to symmetric. Let's move to symmetric. So here our target is we have to interchange A to B. We have to interchange A to B and B to A. We have to interchange A to B and B to A. Symmetric means, symmetric definition says ordered pair A comma B belongs to R, and also ordered pair B comma A should be also present in R. It means we have to reverse the order pair. Our target is to reverse the order pair after interchanging the A and B. Also, if the given relation is satisfied, then that R will be symmetric relation. Okay, so let's consider, let A comma B belongs to R. I have considered A comma B belongs to R. If A comma B belongs to R means we can write by the help of definition, by the help of a given set R defined, we can write 2 divides A minus B. So let A comma B belongs to R. If A is related to B means, how A is related to B we have to write, because 2 divides A minus B, so we call it as A comma B belongs to R. So now our target is to interchange A to B, B to A. Okay, let's see now. So now 2 divides in the place of A, I am going to write B minus, in the place of B I am going to write A. So now values I have interchanged. What will happen if we interchange the two values here? See, for example, if I consider 8 minus 4, 8 minus 4, we get an answer 4. Okay, so 4 is divisible by 2. Okay, well and good. So if I interchange 8 and 4, in the place of 8, if I interchange 4, in the place of 4, if I interchange 8, nothing but here we get a minus 4. Here we get a value minus 4, means if we interchange the value a and b, you may get minus or positive. Negative positive will be changed, but if you observe the value, 4 will be remain same. So if you interchange a minus b to b minus a, there is nothing much change. Sign will be here, sign will be changing, but the value will be as it is. So minus 4 is also divisible by 2. It is working with, it working as a 4. How it work for 4? Minus 4 is also working, which is divisible by 2. So it means if you interchange a to b and b to a, nothing much as difference appeared here, and there is nothing changed here. The relation satisfies itself. Relation satisfies, how relation satisfies for 2 divides a minus b, same relation satisfies for 2 divides b minus a. So which satisfies for all a comma b. Okay, so here we can write which is true. Which is true. If it is true, means we can conclude in the place of a we have written b, in the place of b we have written a, nothing much changed, the relation satisfied. So ordered pair b comma a belongs to R for all a comma b belongs to integer. For any a comma b you consider, this relation will satisfy. So now we can conclude here, therefore R is sorry, here we can conclude R is symmetric relation. R is symmetric relation. R is symmetric relation. I hope you understood the reflexive relation and symmetric relation. Okay, to now transitive relation. Let's now up to now we have showed R is a reflexive relation, R is a symmetric relation. Now let's show the transitive relation. To show transitive relation, our main target is here, see. So we have to consider a comma b ordered pair. Okay, and we have to find a pair which starts with b. We have to find a pair which starts with b. That should be b comma c belongs to R. These both a comma b and b comma c belongs to R. And here we have to eliminate this b. Then only we can find a relationship between this a and c. Then only we can conclude a is related to c. So here our target is eliminate b. Okay, here our target is eliminate b. So we have to eliminate the b here. So first let us consider the pairs now. So let a comma b belongs to R and b comma c belongs to R. So this we have to consider first. A comma b belongs to R, b comma c belongs to R. Now we have to verify a comma c also belongs to R. Ordered pair a comma c which is also belongs to R. To conclude that, first we have to write a order pair a comma b belongs to R. So we have to write same whatever the given R is there, we have to write that relation only. 2 divides, don't change any sentence here. Okay, it will be easy to write. 2 divides a minus b, and here order pair b comma c belongs to R means 2 divides b minus c. Okay, now I have written ordered pair a comma b belongs to R means 2 divides a minus b. Ordered pair b comma c belongs means 2 divides b minus c. So now our target is to eliminate b. So if you observe here clearly, here we have minus b, here we have plus b. Okay, so here I will write here. So a minus b and we have b minus c. Our target is to eliminate this b. So if you want to eliminate b, use any operation or addition, subtraction, multiplication, division. You can use anything, but we have to eliminate this part b. That is our target. So if you observe clearly, here we are seeing minus b and plus b. If we want to eliminate this minus b and plus b, simply if we add these two terms, if we add these two terms a minus b and b minus c, definitely we can eliminate this minus b and plus b. The remaining will be a and this part will be c. So b is eliminated. So the first and the last element is remained here. So first a is remained and the last part c is remained. So it means to get a relationship between a and c, we have to eliminate b. To eliminate b, we have to use any operation here, because b has one b having a minus sign and one b having a plus sign. If we add both, then minus b and plus b will be cancel out each other. So it means we have to add here. Okay, sometimes we have to divide, sometimes we have to multiply, depend upon question. So we can conclude here, 2 divides a minus b plus b minus c, a minus b plus b minus c. So now I am going to eliminate this minus b and plus b. If I eliminate this minus b and plus b, then therefore 2 divides, now the sentence will be 2 divides a minus c. Simple. The 2 divides a minus c. If it satisfies a for a minus b, and if it satisfies for b minus c, definitely it will satisfy for a minus c. So if 2 is divisible by a minus b and 2 is divisible to b minus c, then definitely it is going to divisible by a minus c. Obviously, which is true. If it is true, we can conclude ordered pair a comma c, which is belongs to R for all a comma b comma c belongs to Z for any values a, b, c. If you take any values from integers, so it is going to satisfy the transitive relation. So R is transitive relation. R is transitive relation. Last we can conclude, hence R is hence we can conclude R is equivalence relation. R is equivalence relation. I hope you all understood this part, reflexive, symmetric, transitive. So same way in previous video what we have discussed or what we have written, in same way we have written here, but in the place of t1 and t2, here we are getting a and b. So in previous question we have discussed about triangle and similar and parallel, like those questions, but here we are discussing about numbers, integers, a minus b, 2 divides, in that, like in that concept we are discussing, but the pattern will be same. So our target is to show reflexive b, we have to change b as to a. To show symmetric, we have to interchange the a and b. To show transitive, we have to eliminate that middle part b. I hope you all understood. So if you not subscribe to my video, please do subscribe and also like my video, so that I will get a motivation to do more videos. I hope you all understand this problem. So let us meet you in a next video with new problems. Okay, stay tuned. Bye.